Hello students, so today we will be talking about photodetectors. Photodetectors are those devices which convert optical energy to electrical energy, and they also generate electron transport carriers. So by generation of electron transport carrier effectively means generation of electrical energy. Now we also have something called demodulation, where high frequency optical signal is converted to time varying electrical signal. So some sort of integral transforms takes place. Basically it's a Fourier transform from frequency to time that is causing this demodulation to take place. Now there are basically three main types of photo detectors. A device is based upon photonic to electrical conversion. The first one is called photoconductor. Second one is called PIN diodes. Has been insulated between a P and an N type materials, and lastly we have an avalanche diode. Now the mechanism of a photo conduction consists of light, detection of light, by electrons and hole generation. That means as electrons and holes are generated, that movement will cause a current, and that current is called a photocurrent. Now the wavelength of the light, however, should be equivalent to the band gap of the material being used. Now if there are some extrinsic defects in the material or in the photodetector, then it implies that the energy is less than the band gap, because there will be some, so this is the conduction band, this is the valence bands, there will be some states formed and between the band gap due to this formation of due to the defects. And when they absorb photons, there is transition of electrons between these energy levels takes place, and that actually leads to light emission or absorption. Now, so absorption of photon will take place when light is incident on such a system. and they also are related, as I already said, about the impurity and defect levels in the material. Now, another type of photodetector, or an extrinsic photodetector, is when transitions occur between subband energies. So this is your original conduction band and valence band. So there are some energy levels in between them. The transition occurring between them are called subband transitions, and energy associated with them are called subband energies, and they are like quantum well. And then a difference between these subbands, this energy difference, this is approximately 100 megaelectron volts. These are also called excitonic levels, and such devices are used for far IR detection. Now the quantum efficiency of a photodiode is eta is equal to IPH by Q into P this stands for the incident optical power divided by H nu. So IPH is the photonic current, Q is the charge, P is the incident optical power, and H mu is the energy, quantum energy associated with the light. Now this efficiency is nothing but this eta, which is nothing but the number of carriers. That means number of electron hole pairs generated, or rather collected, to produce the photocurrent IPH divided by the number of photons. So current, photocurrent per photon is actually the efficiency. Now there is something called an external efficiency for the device, and it depends upon the coefficient of absorption of the material used. In short, it depends upon alpha, and it also depends upon thickness of the absorbing medium. working, don't know why. Like this, thickness of the absorbing medium. Which is nothing but A. So alpha and A. So we can write the external efficiency as equal to, or rather it's proportional to one minus e to the power minus alpha A. Now if we again do this, if we again take this ratio, that is IPH, the photon current, divided by the incident power, then we come up with another quantity. It's called responsivity. R stands for responsivity. And it is also equal to eta q by h nu, or putting the terms, that is eta lambda divided by 1.24, it stands for amperes per watt. Now for a fixed value of eta, if we take this eta fixed, then R should be proportional to lambda. That means it should be linearly varying with lambda. So we plot R versus lambda for a fixed eta, then it should have a straight line. The slope is, of course, 1 by 1.24.